Hello friends, welcome to Hydraulics and Hydraulic Machines class. In today's lecture, let us discuss on multi-stage pumps. Multi-stage pumps. So in the case of multi-stage pump, first what do you understand by a multi-stage pump? Multi-stage pump means a centrifugal pump consisting of two or more impellers. A centrifugal pump consisting of two or more impellers. They may be connected to the same shaft or they may be connected to different shafts. If the impellers are connected to the same shaft, then we call it as impellers in series. If the impellers are connected individually, one for each shaft, then we call it as pumps in parallel. So pumps in series, pumps in parallel. Pumps in series means number of impellers are connected to the same shaft. Pumps in parallel means each basic shaft there will be only one impeller. Like that we have different pumps. The delivery pipes of all these are connected. Then why generally we join actually more impellers? The purpose is if you want to increase the head. If you want to increase the head, what is the option to you? The option is either you have to increase the rotational speed of the impeller or you have to increase the diameter of the impeller or both. If you go on increasing the impeller diameter and the speed, the stresses on the impeller will increase tremendously and thereby the efficiency will be drastically affected. Hence, we arrange number of impellers to the same shaft. The same water will flow through the first impeller and again through the next second impeller and again through the third impeller, like that. So in each of the impeller, a certain head, which we call it as manometric head, is impressed upon the water. The moment when it flows to the through the first impeller, the manometric head impressed is HM. Again, the same water with a manometric head of HM enters into the second impeller. Then again it impresses on HM. So HM plus HM, by the time the water comes out of the second impeller, the total head will be 2HM. And if it enters into the third impeller, then 3HM. And if you have n impellers arranged on the same shaft, the total head will be n into manometric head. So naturally your purpose is solved. It doesn't occupy much space. The diameter no need to be increased. The rotational speed no need to be increased, but you achieve your objective of increasing the head. In order to increase the head, we connect the impellers in series. Number of impellers connected to the same shaft. If there is only one impeller, we call single stage pump. If there are two impellers connected to the same shaft, we call it as two-stage pump. If there are three impellers connected to the same shaft, three-stage pump. These three are common. Kindly visit the laboratory and observe. You can see with the moment you see a centrifugal pump, whether it is a single impeller pump or two impellers or three impellers, that you can see. So visit the hydraulics and hydraulic machines lab of your department and then see how many impellers are there in the centrifugal pump. So this is the starting point. Similarly, when the pumps are connected in parallel, the first thing is we want to increase the discharge. If you want to increase the discharge, naturally each pump can discharge certain limits. So now what we will do, so number of pumps are connected, the delivery pipes are connected each one to the other. So the first pump Q1 discharge, the second pump Q2 discharge, third pump Q3 discharge. So the final discharge is how much? Q1 plus Q2 plus Q3. So that is how the pumps connected in parallel. So this is the topic, and let us understand while again the same thing when I put it on paper. Let us go through it. So our topic for today is multi-stage pump. Multi-stage pump. What is a multi-stage pump? A centrifugal pump. Please, once again, I recollect it. A centrifugal pump consists of two or more impellers. Then the pump is called multi-stage pump. The impellers, the impellers may be mounted on the same shaft, on the same shaft actually, or on different shafts. Anything is possible. Then the functions of multi-stage pump are, which is very, very important. The functions of multi-stage pump. Take it number one, basically, to produce, very important, produce a high head. And second function is basically to produce large discharge. Let us take the first one. If the first one is my priority for high head, for achieving high head, the impellers are connected in series. That means number of impellers are connected the same shaft. Water flows through. When I say water, any liquid also you can take. Water flows through first impeller, then the head impressed by the impeller is HM. The same water with HM head enters into second impeller. Followed? The second impeller again impress the head of HM. Therefore, by the time the water comes out of the second impeller, the water comes out of second impeller. The head is HM plus HM to HM. Like this, when they are connected to, when the impellers are connected to the same shaft, the head increases and the total head is equal to N into HM, where N is equal to number of impellers. I can just, for understanding, I have already given the figure to you. If you can refer to the first slide of your lecture, automatically you can see that. But anyhow, I will just show you that also to you. For example, you take this as shaft. So you also in the exam have to write it. So you take it like this. So this is what actually the shaft. For the shaft, actually, I have, so this is nothing but the impeller. This is nothing but the impeller. Like this, if I connect one more for understanding sake, this is the second impeller. See how I am drawing actually. So this is the second impeller. This is the second impeller. Like that, any number of impellers you can draw it. So I have drawn three for making you to understand what will happen. First one is a little bit difficult. Afterwards, nothing actually it is. It is as good as very simple. So three impellers, but of course all of them are of the same size. Only I have shown just while drawing. So what will happen? Let me come to the point. Let us take it actually right. How the thing is, first water flows like this. Water flows like this. Then when water flows like this, naturally it has to come out like this. So when the water enters and when it comes out of the impeller, HM head is impressed upon it, right? This water with a head of HM, actually, what will happen? It will go into the second impeller. This is how it flows into the second impeller. Followed it? Actually, same is the case. So it enters like this into the second impeller. This is impeller 1, this is impeller 2, this is impeller 3. So this also impressed a head of HM. So by the time the water comes out of the second impeller, total head will be 2 HM. So that water actually again it enters into the third impeller. Again, again it flows to the third impeller. Again, this impress a head of HM. So by the time the water comes out of it, what is the total head is equal to HM plus HM plus HM. It is equal to 3HM. I have not changed anything. One impeller, second, third, all are connected to the same shaft. The same water is flowing from first impeller to second impeller to third impeller, and by the time it comes out of the third impeller, total is 3HM. If there are, for example, n impellers, then naturally total head is equal to n into HM, where HM is the manometric head. This is what we call it as pumps arranged in series. We will go into the next thing actually. Pumps connected in parallel. Pumps connected in parallel. Generally, when we connect the pumps in parallel to increase the discharge. This is the thing. So if Q1 is the discharge from the first pump, from the first pump, Q2 is the discharge from second pump, and if the delivery pipes are connected, delivery pipes are connected, total discharge is equal to Q1 plus Q2. If there are n pumps, total discharge is equal to n into. So final conclude. This is again, you can ask me, sir, how to explain it? You show it. No issues. Just I'm drawing how I'm drawing. You see, you know it. This is the shaft portion, right? Or the shaft portion next is in the case of centrifugal pump. This connects to us, right? Figure has not come well. Change it. First is shaft or the shaft actually, the impeller inside, the impeller outside. So these are the veins, series of radial veins, right? When once the series of radial veins are over, then naturally this this is the pump. This is one pump. So what I do is same at the same central axis. What I will do, one more pump I can draw. So this is the central portion. This is the what you call it as the impeller entry. This is outer diameter. So these are the radial veins. This is the second thing. So I have just for understanding sake too. Then what will happen? This is the suction pipe, and at the bottom of the suction pipe, you all know that there will be footwall, and this is the strainer. Generally, strainer will be notified like this, and similarly for this also, suction pipe, foot valve, strainer, and this is the water level here in the reservoir or in the sump source, right? The water level. Then actually what we do, suppose this pump will discharge a discharge of Q1. Now what we have done is the delivery pipes are connected. Delivery pipe. So this pump actually will give Q2. So by the time it comes out, it is Q1 plus Q2. So what we have done is the delivery pipes connected to increase discharge. This is called pumps in parallel. Then otherwise this is, suction pipe. This is also suction pipe center. So now this is how we will do it. If n number of pumps are there, Q1 plus Q2 plus Q3 plus so on. So this is what we call it as the the pumps in parallel. Finally, number one is to increase the head closing. To increase the head, what we have to do? To increase the head, number of impellers connected to the same shaft, that is series. To increase discharge, the delivery pipes of different pumps are connected. Here, pumps are in parallel. So whether the impellers are connected to the same shaft or impellers are connected to individual shafts, as long as your system consists of more than two impellers, then we call it as multi-stage pump. So here I will stop my lecture here.
Like, share, and subscribe. Hit the bell icon for more updates.